NMB cable is indeed acceptable to run up through an island cabinet to feed the required receptacle or receptacles. NMB, which stands for non-metallic sheath cable, is a common type of electrical wiring used extensively in residential and commercial buildings. This cable consists of two or more insulated conductors encased within a flexible, non-metallic sheath typically made of materials like polyvinyl chloride, or PVC, or nylon. NMB cable's approval extends to dry locations, allowing for its use in both exposed and concealed areas. This means it can be routed through walls, ceilings, floors, and importantly, within cabinets and other enclosed spaces. When installing NMB cable within an island cabinet, it is crucial to properly secure the cable to the cabinet structure. This can be achieved through the use of cable staples or other approved securing methods. Securing the cable is vital to prevent it from shifting or sustaining damage over time. Beyond NMB cable, alternative wiring solutions like flexible metal conduit, or FMC, and metal-clad cable, or MC, are also viable options for routing electrical wiring through an island cabinet. Both FMC and MC are categorized as armored cables, offering enhanced protection for the enclosed electrical wires. FMC features the flexible metal conduit lined with a non-metallic sheath, while MC consists of a metal sheath encasing insulated electrical wires. Both FMC and MC hold approvals for usage in both dry and damp locations. Similar to NMB, they can be installed in exposed and concealed locations, including within cabinets and other enclosed spaces. When deciding on the most suitable cable type for wiring an island cabinet, it's essential to evaluate the specific demands of the installation. NMB cable proves to be a suitable choice for numerous applications. However, situations arise where FMC or MC may present a more advantageous option. For instance, if the cabinet resides in a damp environment or if the wiring is susceptible to movement or physical stress, FMC or MC might offer enhanced protection and durability. Now let's delve deeper into NMB cable. NMB cable is manufactured in various sizes corresponding to different ampacities or current carrying capacities. The appropriate size of NMB cable is determined by the amperage of the circuit it will serve and the applicable electrical codes such as the National Electrical Code, or NEC. Common sizes include 14.2, 12.2 and 10.2, referring to the gauge of the wires and the number of current carrying conductors within the cable. The NEC provides tables, such as Table 310.15. B16 that specify the allowable ampacities of conductors based on their size, insulation type, and installation conditions. When working with NMB cable, it is essential to adhere to all applicable electrical codes and safety regulations. This includes properly grounding the circuit using appropriate overcurrent protection, such as circuit breakers or fuses, and ensuring that all connections are made securely. Proper grounding is essential for preventing electrical shock hazards. The grounding conductor within the NMB cable should be connected to a grounding terminal at the receptacle and at the electrical panel. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect the wiring from overloads and short circuits. The size of the overcurrent protection device should be matched to the ampacity of the NMB cable. Secure connections are essential for ensuring reliable electrical service. All wire connections should be made using approved methods, such as wire connectors or terminal screws, and should be tightened properly. Now let's consider FMC. Flexible metal conduit, or FMC, offers a flexible and protective raceway for electrical conductors. It's often used in situations where flexibility is required, such as connecting to motors or appliances that may move or vibrate. FMC is typically made of spiral wound metal, allowing it to bend and flex without kinking or damaging the enclosed conductors. FMC is available in various sizes ranging from 1/2 inch to 4 inches in diameter. The size of FMC required depends on the number and size of conductors that will be installed within it. When installing FMC, it is important to use approved connectors and fittings. Connectors are used to connect the FMC to junction boxes, enclosures, and other equipment. Fittings are used to make bends and offsets in the FMC run. FMC is not watertight, so it should not be used in wet locations unless it is specifically listed for that purpose. If FMC is used in a damp location, the conductors inside the FMC should be listed for use in wet locations. Now let's switch over to metal-clad cable, or MC. Metal-clad cable, or MC, provides a robust and durable wiring solution, suitable for a wide range of applications. MC cable consists of insulated conductors encased in a metallic sheath, offering excellent protection against physical damage and electromagnetic interference. MC cable is commonly used in commercial and industrial settings, as well as in residential applications where additional protection is desired. MC cable is available in various types, including aluminum interlocked armor, or AA, and steel interlocked armor, or JA. AIA-MC cable is lighter in weight and easier to install than SIA-MC cable, while SIA-MC cable offers greater strength and durability. When installing MC cable, it is important to use approved connectors and fittings. Connectors are used to connect the MC cable to junction boxes, enclosures, and other equipment. Anti-short bushings or red heads should be installed at the cut ends of MC cable to protect the conductors from abrasion. MC cable is suitable for use in both dry and damp locations. However, it should not be used in wet locations unless it is specifically listed for that purpose. When selecting the appropriate wiring method for an island cabinet, consider the following factors. Firstly, the location of the cabinet, whether it is in a dry or damp environment. Secondly, the potential for physical damage to the wiring. Thirdly, the need for flexibility in the wiring run. Fourthly, the applicable electrical codes and standards. Fifthly, the budget for the project. In dry locations where physical protection is not a major concern, an MB cable is often a cost-effective and suitable choice. In damp locations or where additional protection is desired, FMC or MC cable may be a better option. It is always recommended to consult with a qualified electrician to determine the most appropriate wiring method for a specific application. It's important to reiterate some safety precautions. Before working on any electrical wiring, always disconnect the power at the circuit breaker or fuse box. Use appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Never work on electrical wiring while standing in water or on a wet surface. If you are not comfortable working with electrical wiring, hire a qualified electrician. Additional considerations include proper support and spacing. In MB, FMC, and MC cables must be properly supported and spaced to prevent damage and ensure proper heat dissipation. The NEC specifies the maximum spacing between cable supports. Cables should be supported at intervals not exceeding 4.5 feet for horizontal runs and 12 inches for vertical runs. When running cables through bored holes in wood framing members, the holes should be located at least 1.25 inches from the edge of the framing member. This helps to prevent nails or screws from penetrating the cable. Also consider protection from physical damage. In areas where cables are subject to physical damage, they should be protected by conduit or other means. For example, cables running along the floor or in exposed locations should be protected by conduit. Cables should also be protected from sharp edges and abrasive surfaces. Remember to use the right tools. Use the right tools for the job. When cutting and stripping cables, use cable cutters and wire strippers that are designed for the specific type and size of cable. Avoid using knives or other sharp objects to strip cables, as this can damage the insulation and create a safety hazard. Also use the correct size connectors and fittings for the cables and conduit being used. Using the wrong size connectors can result in loose connections and potential fire hazards. Regarding grounding and bonding, ensure proper grounding and bonding of all electrical equipment. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. All metal parts of electrical equipment should be grounded to a common grounding point. Bonding is the process of connecting all metal parts of a system together to create a low impedance path for fault current. Now let's talk about some common mistakes to avoid. One common mistake is overloading circuits. Avoid overloading circuits by connecting too many devices to a single circuit. Overloading circuits can cause the circuit breaker to trip or the fuse to blow, and can also create a fire hazard. Another mistake is using undersized wires. Using undersized wires can cause the wires to overheat and create a fire hazard. Always use the correct size wire for the circuit being installed. Another mistake is making loose connections. Loose connections can cause arcing and overheating, and can also create a fire hazard. Make sure that all wire connections are tight and secure. Another mistake is neglecting to properly support cables. Cables that are not properly supported can sag and become damaged, which can create a safety hazard. Make sure that all cables are properly supported and spaced. Also avoid damaging cables. Be careful not to damage cables when installing them. Avoid bending cables sharply, as this can damage the insulation. Also avoid nicking or cutting cables with sharp objects. And always follow manufacturer's instructions. Always follow the manufacturer's instructions when installing electrical equipment. The manufacturer's instructions will provide important information about how to install the equipment safely and correctly. Here are some additional tips for working with electrical wiring. Firstly, always work in a well-lit area. Secondly, keep your work area clean and organized. Thirdly, take your time and avoid rushing. Fourthly, double-check your work before energizing the circuit. Fifthly, if you are unsure about anything, ask for help from a qualified electrician. Let's also consider specific code requirements. The NEC contains numerous requirements for electrical wiring, including requirements for NMB, FMC, and MC cables. It is important to be familiar with the applicable code requirements before beginning any electrical work. Some specific code requirements that may be relevant to wiring an island cabinet include the following. Firstly, receptacle placement. The NEC requires that receptacles be installed within a certain distance of countertops in kitchens and other areas. Secondly, ground fault circuit interrupter protection. The NEC requires that receptacles serving countertops in kitchens and bathrooms be protected by a ground fault circuit interrupter, or GFCI. Thirdly, arc fault circuit interrupter protection. The NEC requires that branch circuits supplying receptacles in dwelling units be protected by an arc fault circuit interrupter, or FSI. Fourthly, cable support. The NEC specifies the maximum spacing between cable supports for NMB, FMC, and MC cables. In conclusion, running NMB cable through an island cabinet to feed the required receptacle or receptacles is generally acceptable, provided that the installation complies with all applicable electrical codes and standards. However, depending on the specific conditions, FMC or MC cable may be a better option. Always consult with a qualified electrician to determine the most appropriate wiring method for a particular application, keeping in mind the location, potential for physical damage, need for flexibility, and budget constraints. By following these guidelines and adhering to safety precautions, you can ensure a safe and reliable electrical installation for your island cabinet.